two basic ways of a function, two basic ways that a function can be written. So we can have a function like this, f of x, let's say f of x to be equal to, let's say 2 exponent x, or we can have f of x to be equal to x exponent 2. So these are the two things that we are going to look at basically. Okay, which one of these is exponential function and which one of these is not exponential function? Now let's look at an example. So example of this, after looking at the example, then we will choose the one that is exponential function. So let's say number 1 and this is number 2. So the example, let's give ourselves like we have equation like this, f of x to be equal to 2 exponent 3, and the second one, number 2, f of x is equal to 3 exponent 2. It's the same thing as the example that I've written here. So in this case, 2 exponent 3 is equal to what? 2 exponent 3 is equal to 8. 3 exponent 2 is equal to what? 9. So you realize that they are two different, they are different between the two functions, right? Okay. Now, if we change it to, let's say, 30, f of x is equal to 30 exponent 2, and then we have f of x is equal to 2 exponent 30. 30 exponent 2 will give us, let's say, 900, and 2 exponent 30 will give us a huge number, 2 exponent 30. So we are going to get something like this from the book: 10, 7, 3, 7, 4, 1, 8, 2, 4, right? So look at the difference. 30 exponent 2, we can write the answer. It's so simple, right? But 2 exponent 30 becomes what? Something that the answer is very difficult to determine if you're not using a calculator, right? So with this, we are trying to, at the end, we are going to draw a conclusion that we look at exponential function when the numbers are difficult to calculate or come by using without using a calculator. Is that okay? So at the end, what it simply means is that exponential function is a function whereby the base, when I say the base, when you have 2x, 2 exponent x, the 2 becomes what? Base. The 2 becomes the base, and then the x becomes what? The exponent. Exponent, right? Where the exponent is unknown. Exponential function is when the exponent is normally unknown. That is why we said exponential function. So when the exponent is unknown, then it becomes exponential function. Now let's look at number 2. Number 2, x becomes the base, and the 2 becomes what? The exponent. But in this case, we know the exponent already. So we cannot draw conclusion that the number 2 is what? Exponential function. But number 1 becomes exponential function because the exponent is unknown, which is what? X. The exponent is unknown. So anytime you have a number or we have a function that the exponent is unknown, then it becomes what? Exponential function. But the base can never be equal to what? 0. The base can never be equal to 0, or it should be greater than what? 1. The base should always be greater than 1 and should not be equal to 1 but greater than 0. That's what I want to say. Okay, let me write it here. The base, so let's say we have f of x is equal to a exponent x. And then we know a to be the base, and we know this x to be what? The exponent. So we are saying that a, which is the base, should always be greater than 0, but should not be equal to 1. It should be greater than 0, but it should not be equal to 1. Please, is that okay? Because we cannot have a 0 if a is equal to 0, the base, when it is equal to 0, and the exponent 0 of exponent of any number is what? Equal to 1. And that is what we are trying to prevent here. So the base should be greater than 0 and should not be equal to 1. Please, is that okay? All right, if that is okay, now let's try to look at some examples that are exponential function and others that are not exponential functions. So for instance, if we have f of x is equal to 3 exponent x, is an exponential function. When we have g of x is equal to 1 over 3 exponent x, this is also an exponential function. And let's say we have the last one to be what? Let's say h of x to be equal to 3 divided by 2 exponent x is also what? Exponential function. Then you realize that this in the form of what? Quadratic or linear to be exponential function. This to be in the form of what? Improper fraction is an exponential function, and this is what? Proper fraction is an exponential function. The only way to determine the exponential function is when the exponent is unknown and the base is greater than 0 but not equal to 1. When the exponent is unknown, when I say unknown, it simply means you don't know it. It should be represented by what? A variable. So in our case, we realize that the exponent is represented by a variable, is unknown. And the base is what? Greater than 1, greater than 0, but not equal to 1. Okay, so these are examples of what? Exponential function. Examples of exponential function. And let's look at examples that are not exponential function. Not exponential function. Number 1, we are going to look at a function like when we have f of x to be equal to y exponent 2. This is not exponential function because we don't know the base, and the exponent is not what? A variable. We don't know the base, so we cannot determine whether this base is greater than 0 or it's not equal to 1. And the exponent is what? Already determined, right? We can also have it in the form of when we have, let's say, g of x to be equal to 5 exponent 2. In this case, we know the base. The base is greater than 0 and is not equal to 1, but the exponent, we also have the exponent. In this case, we don't know what we are going to look out for, right? So this one too does not qualify to be what? Exponential function. And the last one that I want us to also talk about is when you have, let's say, the base to be equal to negative. So let's say f of x to be equal to minus, let's say minus 2 exponent 2. In this case, this one also do not qualify to be called exponential function. Please, is that okay? So these are some of the examples of exponential function, and these are some of examples that are not exponential function. So we will go back to our book and solve some of the questions that are not exponential function or that are exponential function on page 99. I think so. So we are going to solve those questions from question 1 to question 14. All right. After that, let's move on to exponential graph of exponential function. So with a graph of exponential function, there are three things that I want you to take notice of. Actually, two things that you need to pay much attention to before you can draw or plot any graph of exponential function. Okay. The first thing is they are very common to all the graphs. very common to all the graphs. So let's name it as what? Tip. As a tip. So let's say this is tips. Number one, each graph, okay, each graph or each line, let's say graph or line, each graph or line crosses the y-axis, crosses or cuts, crosses the y-axis at the point 0, 1. Okay, at the point 0, 1. Because we are saying that when our b exponent 0, then we get what? 1. When we have any number to the exponent 0, the answer will be what? 1. So when x, in this case, we know that b of x, when you have y is equal to b exponent x, right? And we are saying that if you want to find the values of x and y, if x is equal to 0, in this case, if x is equal to 0, we are going to have any number. If any number to the power 0, then the answer will be 1. Okay, so if b exponent 0, then the answer is going to be what? 1. Exponent of any number to the 0 is what? 1. So y will be equal to what? 1. That's why we are saying that each graph that you plot under exponential function will pass through the point 0, 1. Is that okay? All right. Now let's look at the second item or the second tip. So tip number 2. All the graphs cannot cross the x-axis. All the graph cannot cross the x-axis. So none can cross the x-axis. The x-axis. Because we said that when b of x, b exponent x is equal to 0, it's impossible. B of x to be equal to 0 is impossible. When the exponent assume a 0, there's no way that the exponent b, let's say if you have two exponents, any number, it can be 0, it can be 1, it can be anything, the answer will be equal to 0. There's no way b exponent x will be equal to what? 0. It's impossible. None can cross the x-axis because b of exponent x is equal to 0 is impossible. This is what? Impossible. It can never happen. Okay? Because it can never happen, the line can never cross the x-axis. Let's take a look at these two tips at the back of our mind, and then let's go ahead to try to plot the graph. Let's try to plot the graph. And after that, maybe I'll give you example of the graph sheet, and then we plot it and know how it actually looks like. Right? Now, okay, let's start with that. Let's look at some of the examples. So example of graph of exponential function. Let's say we have exponential function to be what? Number 1, y is equal to 2 exponent x, right? Y is equal to 2 exponent x. From today, we are going to draw the ordered pair numbers and then use it to plot. And after that, we're going to guess them, and we are going to guess them correctly. So with this, we are going to have, our graph is going to look like this. Because it is positive, it's going to slope right from here. It's going to slope like this, right? And this one can never cut the x-axis. We know this is the x-axis, right? And this is the y-axis. There's no way this can reach the x-axis. It will never reach the x-axis. Please, is that okay? Never. So this becomes what? Y is equal to 2x. After this, we will try to draw tables to explain this one. Number 2. So let's say number 2, we are going to have y is equal to 5x, 5 exponent x. Please, when you have the equation or the function, check first if it is exponential function or not, right? Okay, So 5x is also going to give us something like this. The same slope. Okay, it will come this way, it will decrease, but it will never reach the x-axis. So this one too is what? Y is equal to 5x. Now let's look at some that are in a different shape. So when we have an a function like y is equal to 1 divided by 3 exponent x, how does this graph looks like? So this graph will be plotted like this. It will go this way. Okay, it will go this way because it is what? Improper fraction. And at the end, we are going to have our, when we get to decay and growth, right? I'll try to explain this more. But for now, this is how it will look like. We'll go deep on this in our next class. Okay, and then let me see if we have another different one. Basically, this is all that we have. This is how the graph is going to be in the two folds. This one, so we have the one that is increasing and we have the one that is what? Decreasing. In other words, we call it decay graph and growth what graph. We will try to explain that in our next class using some of examples. So basically, this is the introduction of what? Exponential function.